In this problem, I'm going to show you an example of how to apply Newton's second law. I know that this is going to be a Newton's second law problem because it says that we're looking at an elevator that accelerates. So when something is changing velocity, you're going to have unbalanced forces and Newton's second law will apply. But as with every problem that we did last chapter for Newton's first law, we're going to start with the force diagram. A fan with a mass of 65 kilograms stands in an elevator on the bottom floor of Heinz Field. The elevator accelerates upward at a rate of 1.3 meters per second each second. What is the net force on the fan? And what is the normal force that the elevator floor applies to the fan? Just like last chapter, we're going to start by drawing a force diagram, and we're going to do a force diagram for the fan because both of the questions that we are asked are about the fan. So the fan has, of course, the force due to gravity that the entire Earth applies to the fan. The elevator floor is also touching the fan and is pushing them up, and since the elevator is accelerating upward, the upward force on the fan is going to be bigger. So I'm showing the force normal that the elevator applies to the fan in the upward direction. The second step, much like last chapter, is to write a net force equation. But when something's accelerating, the forces are not going to add up to zero. Instead, the forces will add up to the mass times the acceleration. So there are only forces on the fan in the y direction. So in this problem, we only have to write a y direction equation. Force normal minus the force of gravity is equal to mass times acceleration. The other thing that we always know is we can calculate the force due to gravity or the weight of an object by taking mass times acceleration due to gravity. I'm going to start there because I actually know the mass of the fan is 65 kilograms. Therefore, the weight of the fan is 65 kilograms times 9.8 meters per second each second, which is 637 newtons. I'm going to take that information and use it in my net force equation. I also know the mass and the acceleration from the problem. Therefore, I can find the normal force. So force normal minus 637 newtons is equal to the mass of the fan, which is 65, times the acceleration of the fan, which is 1.3 meters per second each second. The normal force that the elevator applies to the fan is 721.5 newtons. With two significant figures, that would be 720 newtons. So that is the normal force that the elevator applies to the fan. The other thing that the problem asks is what is the net force on the fan? The net force is not equal to zero, it's equal to ma. So the net force would be 65 times 1.3. So the sum of the forces, or the net force, would be equal to 65 times 1.3, which is 85 newtons. That's the end of this example problem.